Lucky for us, calculating the pH of a weak base is very similar to the calculating the pH of a weak acid. Just want to introduce some formulas to you first. So when I dissociate water, or when we have a whole bunch of water, like 2 in a billion molecules will dissociate into an H plus and an OH minus. And so the products of that, the H plus and the OH minus, multiply together products over reactants, the reactants being water, so over 1, because I don't include water. So I get this special kind of K constant, K value, called Kw. So Kw are those products. And they have a value of 1 times 10 to the power of negative 14 at 25 degrees Celsius. This, by the way, is how we get how a neutral substance has a pH of 7. So if a neutral substance these two are exactly equal, then this would be equal. So if those were x squared equals 1.0 times 10 to the power of negative 14, then you would end up with 1 times 10 to the power of negative 7 for each concentration, which would mean your pH then is 7, because pH equals negative log of 1 times 10 to the power of negative 7 is just 7. And so that's how I get my neutral substance to be 7. So at 25 degrees Celsius, my pH is 7. At a different temperature, like 90 degrees Celsius, my neutral substance, these two still have to equal, and the pH won't be 7 anymore, because this will be a different value, and so the pH will be a different value. Here's a thought. The definition of an acid is that the H3O plus concentration is greater than the OH minus concentration. The definition of a base is that the OH minus concentration is greater than the H3O plus concentration. Kw equals Ka times Kb. This was the general formula we covered in the last video, that if I do an ice table, I always end up with this expression at the end where X is my H3O plus concentration. So we're going to look at the same thing for Kb. For Kb, for the base, I end up with the same, I could do an ice table if I want, but I still end up with the same boiled down formula that we have x squared divided by I minus x. But here, x is equal to OH minus concentration because it's a base, so the OH minus concentration. And then I have all these other Chem 20 formulas here. Okay. So here's an example. What is the Kb expression and value for ammonia aqueous? So I have aqueous ammonia and water making OH minus and the ammonium ion. So here I have a Bronsted-Lowry base. This is a weak base, right? I'm trying to go weak base. So it has to be my Bronsted-Lowry base. So it has to accept a proton. So here it accepts the proton, which means I form my OH minus. So with my Kb, I'm always going to form OH minus, whereas my Ka, I form my H plus. So the definition of Kb is a weak base in water, forming the OH minus and the conjugate acid. And so here I have my products over my reactants. I didn't include water again because water is a liquid. I don't know where my blue marker's gone. There it is. Because water is a liquid, and so it's not over any water. And then my Kb is equal to my Kw divided by my Ka, according to that formula there. And so I have 1 times 10 to the power negative 14 divided by that I got from my data booklet. So Kw divided by the data booklet value will be my Kb. So 1.8 times 10 to the power negative 5 equals this expression. So what is Kb? It is a weak base in water, forming the OH minus ions. So this is how Bronsted-Lowry said, okay, this doesn't have OH in it, but it produces OH minus, right? Do you remember that? Okay, let's do another example. Okay, if the concentration of sodium fluoride in mouthwash solution is 0.012 moles per liter, what is the pH of that mouthwash? Okay, so in my sodium fluoride and water, in like Science 10, you would have assumed this would be neutral. Ionic compound, it's not an acid, it's not a base. But now in Chem 30, you're recognizing that this is actually a weak acid, or weak base, that this is a weak base because it can be a proton acceptor. It's on my list. Put your finger, find it, right? And so I have this as my weak base. It can accept a proton. It can form its conjugate acid, and that OH minus appears. And so although Science 10 would have predicted this as neutral, it actually would turn red litmus paper blue. So, right. So the question is, what is the pH? It's not 7. It's not neutral. So what is the pH of this solution? So the first thing just like with my weak acid, I'm recognizing that this is a weak base, and therefore I have to use Kb before I can use my pHs. That's what I'm recognizing. Okay. This is a weak base, so I have to use Kb before I can go and do my pH. So because it's a weak base, I write the expression, right, based on the reaction here. Now I need to solve for Kb. So Kb is equal to Kw divided by Ka. Kw is 1 times 10 to the power negative 14. Ka is in the data booklet, and it is 6.3 times 10 to the power of negative 4. So my Kb is equal to 1.6 times 10 to the power negative 11. So 1.6 times 10 to the power negative 11 is my Kb, and this is my expression. Now, I could do an ice table, and my ice table would boil down into my x squared divided by I minus x, where x is the OH minus concentration. So this is equal to this divided by my initial concentration minus the x. Now, just like with my acid, if I have it, I will use it. If I don't have it, I can lose it. So I'm assuming that this is not going to change by much. So it's look at how small that Kb is, right? Just a tiny bit of it dissociates or accepts a proton, like hardly any of it though. 0.000116, that's crazy. Okay, so anyway, that's approximately x squared divided by that number. I've lost the x at the bottom. Don't lose the x at the top, just the bottom. Okay, so I have this, x is equal to that now, right? Just algebra-wise, figured that out. And what is x again? Oh yes, if I'm using Kb, x is my OH minus concentration. I'm not done, this isn't math. You're not solving for x, circling it, and moving on to the next question. I have to actually think through this. So here, this is my x. Value equals my OH minus concentration. So my pOH equals negative log OH minus concentration. That's my pOH. And so my pOH is 6.36, but it asks for my pH. So my pH is equals 14 minus my pOH. So my pH is equal to 7.64. Is that the pH of a weak base? You bet it is. So this toothpaste would have a pH of 7.64, not neutral, even though in Science 10 you might assume it's neutral. Okay, so the trick about Kb is, or the trick about calculating pHs of a weak base is you first of all have to recognize it's a weak base, then you use your Kb to solve for your pH.